Welcome to the ABB Doc video tutorial. In this lesson we will be looking on how to create a single line diagram using the ABB Doc software. ABB Doc is available through the installation of ABB eDesign. Please ensure that you have the latest update of the software. Thank you. When Doc starts up, the pop-up window Project Wizard opens. In this window it is possible to insert the project name, descriptions and customer's name. Then choose the configuration of the project. You may either draw and compute the single line diagrams or select switchboards and draw front view representation directly. Firstly, we need to select the type of short circuit calculations according to the standards. In this example, the international standard IEC 60909-1 was chosen, and the IEC 60364 international standard for cable dimensioning was chosen. The type of power supply can be chosen among low voltage supply, supply through MVLV transformers, and also for low voltage genset supply or medium voltage genset supply for standalone installation. In the Options menu, you may select the standards for miniature circuit breakers, IEC 60898 for civil applications or IEC 60947-2 for industrial applications. In the Circuit Breakers tab, you may insert the maximum rated current for miniature circuit breakers or molded cased circuit breakers. Doc contains simple empty page with different sizes for free drawings, or different types of column layouts below the page to represent diagrams of the switchboards. In the Power Supply menu, you may insert the calculated three-phase short circuit value for low voltage distribution supply. Alternatively, you may select the number and characteristics of the MVLV transformer. Next, define the characteristic of the LV network by setting the rated voltage, the number of conductors, the type of distribution system, and the frequency of 50 or 60 Hz network. The following step is to define the switchboards available. You may select the proper usage category and segregation form. It is possible to insert any desired name for the switchboards. Click the green plus sign to insert another switchboard. Then click Finish and you'll be reverted to the single line diagram layout. The chosen power supply will be readily drawn on the single line diagram. You may zoom in and out with the mouse scroll or using the zoom options at the top of the window. To draw low voltage single objects, go to Low Voltage Symbols and select the component you need. The Connections option allows to extend the connection to the desired position. Then hover over to the Circuit Breaker section to select the incoming circuit breaker. Left-click to place the object at the connection and right-click to exit command. Double-click to enter circuit breaker properties. You may insert any description to the breaker. And click OK. Then select the busbar object to insert busbar. It is similar to drawing connections. Now you may draw the feeder loads. Firstly, draw the outgoing circuit breaker and insert the feeder description. And click OK. You may continue inserting another circuit breaker with a left click. And finally right-click to exit command. Then insert the cables for both feeders. Then insert the loads. Make sure to enter the feeder properties by double-clicking the load symbol. Insert the cable length of the feeder. Select the installation method of the cables. And also the type of cables. Then insert the rated current of the load. In this case it is 1500 amperes for the first load, and 250 amperes for the second load. The first two feeders were created with a combination of single objects. To draw a few single objects at once, you may use the dedicated macro options at the top panel. For example, select the motor feeder macro. Enter the description and cable length. Then double-click to insert the properties of the motor. You may change the properties of the motor by inserting into the available boxes, or choose the readily available motors by clicking the binocular symbol. Use the sort option to ease the finding of the motor. In Doc, it is possible to modify the length of the connection by using the Stretch option in the Home menu. Left-click to select the connection and move to the length you desire, and left-click to confirm the new length. Next, we can create a bus tie switch by selecting the disconnector object. You may use the Rotate function to rotate the object by 90 degrees. Left-click on the disconnector, and right-click to rotate the object. Continue to draw the bus bar after the disconnector. There is also a macro feeder to create a cross-reference feeder to another switchboard. In this example, we will look at the sub-switchboard feeder with switch fuse. Insert the description and cable length. And select the other switchboard. Select sub-switchboard 1 and click OK. Right-click to exit macro feeder command. Next, go to Home menu to add a new page. Select Cross-Reference End, and select the feeder to continue. You may go back to the previous page to double-check the feeder's description. Continue to insert bus bar. And also a macro generic load feeder. Insert the load for the sub-feeder 1 and click OK. You may create another new feeder by continuing to use the left click again. Or you may highlight the feeder. Use Ctrl-C to copy and Ctrl-V to paste. Then left-click to place the copied object that has identical properties. Change the description of the second sub-feeder. Next, add another generic load feeder macro for the last feeder. To insert the generator power supply, we need more space to draw. Hover the mouse to the home panel to change the page layout. Select A2 or A1 size drawing for a bigger layout. The generator object is located in the power supplies drop list. Select the generator of your choice. Then insert the generator circuit breaker. Insert busway or cable. Then complete the connection. Make sure to insert the length of the busway. We can now create different scenarios for the network. Take note that QF9 circuit breaker protects the generator. QF1 circuit breaker is for the utility. QS1 disconnector is the bus tie switch. Then select Scenarios. For normal operation, the generator circuit breaker is turned off. Therefore uncheck the QF9 generator circuit breaker. Click the plus sign to create another scenario. Name it Emergency and press Enter to save the name. During an emergency, the utility circuit breaker and bus tie switch opens, and the system is supplied by the generator circuit breaker to priority loads only. Therefore uncheck QF1 and QS1 for the emergency scenario. You can see that there is a difference in color. The objects in black are supplied by the generator, and the other objects in red are not supplied. In Doc we can perform calculation for each scenario individually. Select Compute and select Calculate Actual only. So, Doc will calculate based on the emergency scenario and size the devices accordingly. As you can see, the calculated maximum short circuit IK max is 6.4 kA. Now, change the scenario to normal operation and compute again. This time, the maximum short circuit IK max calculated is 10.4 kA. After computing, you may see some errors that are highlighted. For instance, the cable of the feeder 1 shows an error. You may open curved software to check where the problem is from. It could be overload, short circuit, or indirect contacts protection failure. In this case, the cable has a warning for indirect contacts. Select the error and double-click on the time current curve of the circuit breaker to adjust the threshold. Select minimum IK and adjust the I function of the T7S breaker to ensure the cable is protected from indirect contact. Now the warning disappears. Exit and save the changes in curves. The warning disappears. As a summary, you may choose the option of Calculate all scenarios. In this case, Doc will size the components based on the worst-case scenarios. As you can see, QF8T-Max-T5 circuit breaker is the downstream device of the QF9T-Max-T6 generator breaker. Doc has the option for discrimination and backup between upstream and downstream devices. Select discrimination with downstream device and click OK. Then select Compute again. Now the upstream device has changed from T-Max-T6N to a larger T-Max-T7S circuit breaker for full discrimination. You can also renumber the devices in order sequence from top to bottom. It is also possible to change the type of information you want to show on the single line diagram in Set Labels. Now you can see all the label information chosen earlier. In Doc, you can also export to DWG format. In Print Manager, you can choose the type of information to publish in the printout. You can also save the file to be opened in CAT software, in order to extract all the ordering codes of the components from the single line diagram. Thank you for watching.